Okay, welcome back to Math Review for Matrices. And before we get into how to set up a matrix to solve a system of equations, we need to talk a bit about how to use a matrix to solve it. So, this is the generic form. A, which is your coefficients, x, which is your variables, equals C, which are your answers. To determine variables, divide each side by A. And that would give me x equals C over A. But remember back to exponents, where this is the same thing as C times A to the minus 1. And this is what's known as the inverse matrix. It's the matrix multiplied to A to give identity matrix. Just like how 5 times 1 over 5 equals 1. A times A to the minus 1 equals the identity matrix. And for 2 by 2, which is what we're going to work with, the identity matrix is 1, 0, 0, 1. So, let's talk about how to find that identity matrix, because without that we can't really do anything. Oh, sorry, not to find the identity matrix, to find the inverse matrix. Let's say we had two matrices, W, X, Y, Z, to be A, B, C, D to be A to the minus 1. I could go through and show you exactly how we would solve this to figure out what each of the things are in A to the minus 1. That would take a lot of time. I feel like I would lose a lot of people, so I'm just going to stick to what everything is. So A is Z over WZ minus XY. B is negative X over WZ minus XY. C is negative Y over WZ minus XY. And D is W over WZ minus XY. Alright, so those are the formulas. Notice how the denominator is the same for everything? We're going to just give it its own name. We're going to just call it T. So the a to the minus 1 is z over t, negative x over t, negative y over t, and w over t. Alright, so that's how you find the identity matrix. So first find t, oops, not fid, find t, 2, solve for a, b, c, d. So here's an example. Let's say A was 1, 2, 3, 4. What would a to the minus 1 be? So first I got to find t. T is 4 times 1 minus 3 times 2. If you're having trouble figuring out where everything is, label it on A. This is W, this is X, that's Y, that's Z. Four minus 6, which equals negative 2. So a to the minus 1, z over t, 4 over negative 2, negative 2 over negative 2 for this one, negative 3 over negative 2, and then 1 over negative 2. Which, of course, we can do some reducing. We get negative 2, 1, 3 over 2, negative 1 over 2. Now, I wish I had more room on this page because we're going to actually prove that that works. So, that means that, remember, a times a to the minus 1 would have to equal I. 1, 2, 3, 4 times negative 2, 1, 3 over 2, negative 1 over 2 would have to equal 1, 0, 0, 1. And it's always row by column. So 1 would have to equal negative 2 times 1 plus 2 times 3 over 2. Does 1 equal, by the way, that's a question mark if you can't tell, negative 2 plus 3. That does equal 1. Now we're going to do the next set. Does 0 equal 1 times 1 plus 2 times negative 1 over 2? 1 plus negative 1 does equal 0. Look at that, it's working. Alright, 0. Does that equal? Now, okay, this is going to be tough to do. There we go, actually. Now I'm moving down to this row, times this column. 3 times negative 2 plus 4 times 3 over 2. See, I get negative 6 plus 6 does equal 0. And let's do the last one. If those three have worked, this one should work. We get 3 times 4. Oops, sorry. Got ahead of myself there. 3 times 1 plus 4 times negative 1 over 2. Three minus 2 does equal 1. So there's our inverse matrix. Now in the next video I'm going to show you exactly how an inverse matrix actually works for solving a system of equations. So I'll see you there.